Hey folks, I just wanted to just document my rough thoughts on the M65 debug tool. I haven't talked about it for a few years, so I thought maybe I should just rattle on about it a little bit. Um, it's going to be boring, especially if you don't like debugging, so you're welcome to switch off if that's not your cup of tea. So just to remind it, when I debug for the Mega 65, I think my ideal experience of debugging is with this updated branch. I forked Gabor's Zemu and I made some tweaks to it. Many of my tweaks have gone back into official Zemu, but there's still a few that are remaining here, so I still tend to debug via that one. So if you want to grab that one, you're welcome to visit that GitHub site, and it's on this 220 UARTmon update branch. And yeah, you just check that one out and build from there and run against that one. Hey, yeah, I know I had this big long list that's going to be pretty dull to get through. Maybe though I should start with what got me onto this topic. I think when I saw Lippy's new game on the file host, yeah, might as well look at that too. It's an awesome game. Um, Here we go, The Woods of Peril. Yeah, I grabbed this one and had a lot of good fun with it. But yeah, there was a basic bug in it, and yeah, I did want to debug that basic bug. Yeah, it's a really good sort of. It reminds me a lot of Lands of Lore or those style of games. And yeah, but there was a basic bug of Formula 2 complex error, and yeah, sorry, I know I'm not very organized this time around. What am I doing? All right, so I'll get the debugger out. That's one thing I'll do. I'll also get Zemu running with the Woods of Peril. Um, and maybe the error line. Um, the error line, or the error used to happen with the Ghost of 1000 on this line. And I'll run it like that. And the problem was, hopefully the volume of the music's not too loud. Maybe I'll bring it down just in case. All right. Oh, that's maybe really loud. Okay. And yeah, as you play the game, a new game, yeah, keep the settings. Me, keep, and then W to exit into wilderness. So you move around with the cursor keys, and it's an awesome looking game. But as you move around, you'll bump into baddies. Um, Hopefully, I'll bump into one soon. Come on, baddies. Ah, here we go, a wolf. So I have this choice of fight or run away. But I found, actually, maybe this is a good time to jump into m65 debug. And I'll just clear that. And there's a new command of a basic backtrace. So if I run that and stop the CPU, it runs a little slow, but yeah, frame by frame on the basic stack, it figures out, which goes subcalled, which goes. I think do's and fours are also part of the basic stack as well. And yeah, I think it's almost there. Yeah, there we go. So yeah, that's where it is right now. I'll do T0 to unlock the CPU. The problem seemed to happen on the runaway. If I choose to run away instead of fight, it comes back out here. Maybe if I do another backtrace, basic backtrace, I'll do another one. Again, a little slow, sorry. Maybe there's ways to speed this up later, but first implementation's always the worst. It'll get better after that. Yeah. All right. And yeah, I guess see how the backtrace is getting slightly larger. And I guess it relates to this Ghost of 1000 line. Every time you run away, it seems to recurse into another Ghost of 1000. So if I do this fight or run away multiple times, I'll come back into the game. Run away. Sorry. Yeah, let's find some other baddie around here. Any baddies? Okay, another baddie. I'll run away. That's it. Any more baddies? Ooh. It's pretty awesome that this is all written in BASIC, so Lippy did a great job with this. Okay, baddie, run away. Okay, we'll try that again. Be back. Again, we'll be a bit patient here. I know it's a little slow, and probably I shouldn't have done it as a live stream, but probably a bit more pre-prepared video perhaps, but just time is limited, so this is a little easier to do. But anyway, hopefully you're starting to see that this the basic stack is getting consumed more and more each time we run away. There's these calls to go sub 1000 that are accumulating one after the other. And yeah, the more I did this, after 15 minutes of playing the game, the more, the game consumes that basic stack until it's exhausted. And then we got this, what was it, Formula 2 complex error. It showed up like that. Yeah, so I won't do that now, but this was more just a demonstration that sometimes it might be handy to get a nice preview of this backtrace of the basic program, what's calling what. So here we see, like, on line 1030, it's likely gone to the go sub 8200, and in there it's done, go sub 1000, and then inside the 1000 it's gone to 1030, and another go sub 8200, and in there another go sub 1000, and it's sort of recursed and recursed and recursed in this fashion. So yeah, it can be a good way to study, why these things are happening in your program, in your basic program, I mean. Okay, so that's that. So I'll just exit out of that, and I'll try and rush through the other things on the list. Some of these, even I've got a vague, sketchy memory of them, and I'm not going to do a good job of explaining them because I forget the context in why I added some of them. M-copy, that sounds interesting. Is it still there even? Help. M-copy. Yeah, copy from a source to a destination of a certain count. Okay, that sounds useful under the right circumstances. PMF and WMF commands to print and watch basic float value at a given 28-bit address. Yeah, that sounds interesting, but I can't remember how to use it. I think it's got something to do with the basic variables. The PBAS will print the basic variables. Some of these are likely to be floats. Let me see if I can spot a float. Where's an interesting look? Well, I guess all of these are floats in a way. D9. Alright, D9 is 16. Is there a symbol D9? Oh, there must have been a way I added symbols. Was it like that? Yeah, D9. Okay, so the symbol D9 is at F7B5. I wonder if I just dump that location, F7DB, is it? Yeah. That looks like it might be the float. Let's try. So PMF F75B 16. Okay, that's cool. And I guess I can even use the symbol name that's which symbol was it again? D9 was it? PF. Yeah. All right. So if I do PBAS of D9, okay, they match. Okay, so if for whatever reason you wanted to watch a basic variable, you could probably do that then. Watch D9, and then in your watches, you'd have a watch list, and as you're stepping through your program or breaking from time to time, you could keep tabs of a float variable. Okay, that's interesting. Okay, so yeah, that might come in handy for basic programmers. The char command, vague memories of using that. Help char. I believe it was to plot out the characters at certain points of memory. I remember using it for, I mean, if I put a char index, it'll probably just do garbage because I don't know good locations where they're stored offhand. But yeah, I'm sure somewhere there's an interesting point in memory where there's some interesting characters. Yeah, that was char. And I think sprite was similar. Sprite was, I remember using this more when debugging, or what do you call it, reverse uh, engineering. What was that game? Seawolf. So it's these are very Commodore 64 era chars and sprites. So I haven't done anything for like the Mega 65 sprites or anything like that. So yeah, again, sprite index, you could do the same thing there. Get a quick dump of what those C64 like sprites are in memory. For me, that's either sprite index, or you could put an absolute address somehow. Help sprite prints out bits of sprite. I think it could take an absolute address, but I probably haven't documented. Yeah, based on the currently selected Pic2 bank, if the index is in the form of a dollar sign and that, it is treated as an absolute memory address. Okay, so if you did like whatever C000, it's whatever is in that memory at C00, which is nothing right now. I don't know, 800, whatever. Yeah, that might come in handy. The set command. Okay, it just wraps around the S command. So the set command was, maybe I can demonstrate that. It's, yeah, like if I did S800, 1, 2, 3, 4, we see over here it's dropped those on the screen. So the set command is pretty much the same. Set 800, you could do the same for 5, 6, 7, 8. That's it. But I think the improvement there is that you can start using symbol names for things, for values, or even so if you're debugging something and you have, I don't know, how do we do it? Is there a quick way I guess I can watch a location 800 and I'll give it a fake symbol name. I'll call it screen. And then I think a symbol name screen will point to 800. So that's a dodgy way of adding a symbol name into the symbol list. Can I just delete all the watches? I don't need the watch. I just need to. So then you could do set screen to, I guess 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, and I think you can use symbol names for the values too from memory. So yeah, that's pretty handy when you're debugging something alongside, a compiler's list files and map files, and you've got all the symbol names. So that's set. Next command was something ZEMU only, but it can step over macro usage. That's kind of hard to demonstrate on the fly. From memory, it was when I was working on 11 with some of the assembly stuff. If I can open stuff like that here, and I look for plus macro. Can I look for plus macro? Plus macro. Actually, that's not how it works, isn't it? There's a macro and then all the names of the macros. A lot of my code had lots of macros in it. And when they're used in the code, they're used with a plus sign at the front. And in the past, when I used like stepping command, you'd step into the macro, uh, you know, item or assembly opcode by assembly opcode, and that was getting annoying. So I changed the next command to be aware of macros and skip over the entire macro as you step through it. It's kind of hard to demonstrate now and too time consuming. But yeah, if you're using Acme and you're using macros and you like the idea of stepping through code like this where here's one macro followed by another macro followed by another macro, and you just want to go steps next, 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 next. Yeah, you can do that now. So I think I'll say that briefly about the next command. Um, the reload command, that's pretty useful when you're rebuilding things. So, all right, maybe if there's a way to quickly demonstrate, I'll try. Again, it's been a little while since I've worked on this project. So, was there a ZEMU in here? There is. All right, if I was to run that ZEMU, all right, make ZEMU inside the 11 project. Is it starting up? No, it's not starting up. Um, there's probably an error message or something. Let me just copy that, see what the error message is. Okay. It says no such file. What have I done? Really? Pretty sure there was. Ah, okay. It's built. It's run in m65dbg. All right, I'll try that. Yeah. Make zoom. All right. Yeah, my mind's at a mess to know how I'm going to demonstrate this. But what can I show? For the reload, I guess it'd be debugging in the 11 folder. So you'd be running m65dbg inside this 11 folder. You'd get all the can I show all the symbols? I forget if there's a way to. Is there stuff starting with A or starting with dot? Oh, no, I guess maybe it doesn't do that sort of thing. Um, oh, maybe it can handle a hex range of symbols. Okay, so what if I say from this range maybe? There's one called var table. Okay, and the symbols in there. There was probably a way in the project to rebuild things. Again, I haven't touched this project for a while, so it's hard to demonstrate this stuff. Probably not the best time to refresh my memory. Okay, rebuilding the test. I, I guess it's running Acme. It wants to build this 11 pass prog, and then it's going to attach it to the D81 disk and put this parser in. Okay, right. So if I run, okay, let me try. If I run, okay, if I run make test, okay, so it ran Acme, it created a new symbol file, it created a rep file, and they can be reloaded into the debugger. If I type reload, yeah, it reloaded those two into the debugger. So if for whatever reason, the locations of these symbols changed, instead of exiting uh, m65 debug and reopening it as I used to do in the past, which gets quite annoying because you might have set up a list of watches to follow and then you lose it, or you might have lost other things that you had set up. Yeah, you can stay inside m65 debug, rebuild your assembly stuff and just re-import all the list and symbol information in that way. Yeah, so that's pretty handy. Yeah, okay, the go command wraps around the raw G command. So in the past, I don't know, help go. Okay, so G command is one of the old raw commands. G address, set the PC to a certain address. But the only improvement Go does over the top of that is that you can do like any symbols for your compiled program. So if you've got a symbol name like main, you could say go main, and the PC would straight away move to main. Okay. Register output now shows char value of registers. Yeah, that's true. So if I do R, uh, ah, at least I thought it was true. Oh, maybe it's only true when we're watching. Okay, watches. Maybe I'm mistaken. Or is it when we're stepping? Ah, it's only when we're stepping. Okay. Then we see, okay, so it's not exactly true. It's all the time. When I do R, it doesn't have this extra line at the bottom. But now, when you step through code, I've added this third line here that shows the character equivalent of, A is 0, X is this, Y is that. This came in handy when I was debugging like string manipulation routines or string parsing routines. And A would equal one of the characters, or some of these other variables will equal the current character. It just made it easy to follow along the journey. So if for whatever reason, I don't know what's a value, 25. Up. So up. No, it didn't happen. No, A was 25. Okay, so if A is 25, then it just shows underneath 25 means the percentage sign. If I load it with 26, we see it's the ampersand. So it was an easy way to follow things like that when you're debugging string routines. Yeah, that's history of past commands are preserved in a history text file. Yeah, this was kind of handy. So if you do happen to quit the program now, you'll see, well, you don't have to really care so much. There's a .history text file in there, in the whatever folder you ran m65dbg in. And if you go up key, up key, up key, yeah, you have all your past commands that you had typed in this project. I found this kind of nice because, if you jump to another project, whatever, silent, and you do m65dbg, then if I do up here in here, I get all the past commands I did for that project. So it's nice that it's unique per project. Well, at least I find that useful. Okay, get help on specific commands. Oh, you've seen that in action already. So if for whatever reason, I know there's a load command, but I don't know how to use it, I can now type help load. Or there's a help save command. Sorry, help save. Sorry. So I can read the details of how to use the command or help seam. Yeah, so on. That's you can now set values in memory with new commands like the pokes. Yeah, that's just to make it sort of similar to. Well, we can give that a try just for fun. See if we can change the screen color. T1. Yep, is it stuck? Okay, I think it's stuck. All right. Okay, let's try poke D020, 1. Yeah, 2, 3. And I guess D021 after that, so you could change the foreground color too. Yeah. Let's see what else. But in all their equivalents, like poke is a 16-bit or poke is a 32-bit number or poke is a 64-bit number. They're all there. The mpoke and mpokew, the distinction there is if you're in 16-bit address space with the mapped memory or absolute 28-bit address space. So you can poke either way. You can make the ROM readable writable with ROMW now. I found that handy if you're debugging in the ROM code. So if I maybe bail out of here, uh, maybe if I jump to the ROM, x65 ROM, and run m65dbg here. Maybe I want to break somewhere in the ROM, break on, is there a play command? Okay, and if I go play EDC, I press enter, now the CPU's paused, and if I disassemble there, it's on the play command there, ready to step through bits and pieces there. And for whatever reason, if I did want to change that part of memory, it's technically not allowed. I guess I could try set for A9B to be, right now it's D0, what if I change it to D1? And then I do that again. I see down here it's still D0. But if it's ROMW, you can either toggle the current state by just putting no parameter, and it'll toggle backwards and forwards. If I do ROMW again, it'll become read only. Or you can enforce it one way or the other with 0 or 1, that's off, or sorry, writable is that one, 1. Yep. So now if I borrow that same line again, set for A9B, this one here for A9B, sorry, to be D1. Okay, I'll press enter on that. And if I disassemble again, hey, it still isn't changed. Why is that? Alright, either that's a bug or... probably because it's not in the right point of memory. Yeah, sorry, my mistake. This is probably... maybe I should use poke instead, because that's in 16-bit. Yeah. Yeah. I'll use poke instead, so it'll be 16-bit mapped memory. Alright, how about now? So now disassemble. Yeah, it's changed to D1. And I can poke it back. D0. Disassemble. Yeah, BNE. Sorry, D0. And let me try ROM, make it read only again, just to confirm that we can't change it anymore. I'll change that address to D1. Disassemble again. And yeah, it's definitely read only now. So that's that one. So we've done that. Dereferencing 16-bit pointers, even via symbol names. For this we'll need to like dig into symbols, like some example with some symbols in it. I don't know if I can easily set something like that up. Alright, since we're in, where were we in before? 11. Inside 11, is there a pass test? ASM. So if it runs the test, is there an interesting point in the test program where I can put a breakpoint? It's been so long since I've done this. Test read next line. Alright, maybe I should try that. Test read next line. Alright, M65. So if I was to start this up again, load a program. I don't know, is there a test program I can load on this disk? I don't know. I'll try one. Fieni.l. And if I press F5, will it then run the tests? Let me check. No, it doesn't run the tests. Alright, I thought make test would copy the test program over. Oh no, it's not happy to do it. Cannot open the file. Okay, I shouldn't run it from here again. I should run it from here. Make test. Okay. So it's written the pass. Yeah. Oh, because it's in memory. Okay, yeah, I gotcha. Yeah. Maybe I reset and try that again. F5. No, it still didn't run the test parser. Okay. Um, so I shouldn't do this. Deload 11 pass list. Oh, it's still the basic one. It should be. Oh, it's copied it to which one? The copy, deleting, attach. Oh, it's done it on the other 11. Oh, okay, not the one here. Okay. So if I mount this 11 and deload 11 pass list. Yeah. Okay. And if I run that one, then it's all these tests. Yeah. Okay. I gotcha. My mistake. So then if we go to m65dbg and if we run those tests again, so I can maybe break on one of them, test underscore underscore. I did a tab to see all the tests I could potentially was there something about read next line? Okay, break on read next line. So if I run these tests again, okay, we've broken somewhere. Maybe I'll just use mapping to clean up the screen a bit. Oh, it's on this first line. Okay, so what were we trying to demonstrate here? Pointers. Well, I guess I'll do where are we now? This. Alright, do we have any interesting pointers here? Oh yeah, okay. Load A with 2. Okay, but this is a 32-bit pointer. I'm just stepping through this. Source pointer, can I print? It's double, sorry. Okay, it's gone there. But yeah, this is a feed dummy string. Are there any pointers in here of interest? I think we'd need like a story. Okay, ret pointer low, ret pointer high. Okay. What does that equal? Ret pointer low is equal to 6fc2. Right. Okay. Or at least for now. After this addition, what's it equal? Alright. Ret pointer low is now 26c2. I don't know what's that, 26c2. Maybe I should dump 26c2. Oh, it's got this output text. Alright, yeah, okay, that's an interesting example. So if we were to dereference, like if I was to say, let's say, I might be tempted to say PS ret pointer low. But that's not right because that will try and print a string at the address of that symbol, which is, where is it located? It's located at address 6. But if we were to do print string at ret pointer, we get the actual string of text at the location where the pointer is pointing to. Okay, so hopefully you can see how adding the asterisk there can dereference the pointer. So yeah, that's handy if you're debugging things like that with a lot of pointers. Oh yes, and you can have like a pointer to a pointer and do a double dereference like that as well. Okay, the mapping command. I guess if you're curious how things are mapped in memory at any point in time, you can type mapping, and it tries to give you the lowdown of how things are presently mapped in memory. What's it trying to say? In the mapl region under 8000, it's saying that just actually it's not terribly exciting in this case. How about I exit and go straight to basic? Oh, still, yeah, okay. When basic's on, it's a more interesting mapping. I think when assembly is running, maybe it's not so interesting. Okay, so map to the 2000 to 4000 region is bank 3's. This is part of the ROM. A C65 basic chunk has been mapped to the 2000 to 4000 region. It's saying in the 4000 to 6000 region, part of the ROM in bank 3 from 4000 to 6000 has been mapped into here. And at 6000 to 8000, then part of the ROM has been mapped there from bank 3, 6000, another basic chunk. And in map H, which means 8000 and above, in 16-bit memory, we see C65 basic chunk, another basic chunk has been mapped there from 8000 to A000. And yeah, another basic chunk mapped to 8000 to E1000. And yeah, and in E1000 to FFF, yeah, it's the editor and kernel. And there's other things that can affect the mapping. There's this register, so we get a sense if anything's been mapped relating to that register, and yes, it does seem so. The C1000 location has got this DOS stuff, this DOS chunk and kernel chunk mapped in there. And also there's the old C64 register, and that's also is mapping in the IO at this D000 location. In addition, I've added to the mapping command this stuff at the top where it tells you what map H and map L are, which you can get from the R command. If I type R, we have map H and map L over here. But what's missing from the register information is which megabyte they relate to. And so this is the extra information here that you'd get the first 32 palette colors and all their values that they're consisting of RGB values. You could, just to help palette to remind myself, I think the values are, maybe we should try and load a game. T0, what if, what about mount, Mega 65, boot? No, I've got the, what if we look at the palette for this game? Yeah, a lot of it's 0. Okay, but yeah, we see a lot more colors in here. Alright, now we'll just pause that for a second. So, okay, the audio is a bit annoying, so yeah, I won't do that. I'll just exit. Is there another? What's happening? Oh, I must have set another breakpoint, did I? No break. I don't know why keeps on breaking. Let's do help seam. So seam will take a row and a column, or optionally a column actually. So if I were to do seam 0, 0, what does that give us? It's a special character shown in red. It's a go to X bit character, and so it's going to -1. I think this relates to he's doing some sort of scrolling technique with this go to X at the first character on the list. What's that? It's a background character, and I guess the green one, is overlaid on top of it. So if I go 2, if I go 3, if I go 4, how many characters would it be? I don't know. 10. Anything else interesting? Probably, well, if I don't do that, actually maybe it's better, I'll do just the row. It's going to go through one by one and show me all the characters. And at some point you'll see most of it is background initially. Then you've got some set commands to bring it back and draw things on top of that. And there's probably another set command to bring it back and start drawing the score characters. Yeah, so it can be a good way to sort of play around with things. So if I was to go back and maybe look at one of the score characters, maybe we can have a bit more fun with it. Alright, so let's see, we've got, where's one we can play with? Okay, this one is seam064. It's one of the zeros up here. And let's play around with this char number field. Right now it's set to char number, is it 0D1D? I wonder if I can play with that. Okay, let's do seam064. So if I want to change the char number, I can, let me give it a try. I'll try 0D1E. Oh, something flickered there. Maybe I have to pause it and do it that way. 0D1E. I tend to run mapping if I just need the CPU to move along a little bit so I see the change. Okay, so by changing it just by 1, you can see I can have a fiddle with the sort of scene properties manually. Like if I do that and type mapping, let's take a look. I've changed it again. Whatever, 1, 0. That hasn't changed to anything interesting. Okay, maybe I picked a bad value there. I forgot what it was originally. What was it? Maybe E, was it? Yeah. No, it was D. Okay. Mapping. Yeah, I got back to what it was. But also, oops, you can change any other field as well. Maybe there's other fields you want to play with there. There's the right hand side trim. Let's say if we wanted to play with right hand side trim. Right now it's 0. What if I trim 4 pixels off it? What will happen? I'll do mapping again. Yeah, you can see that character has had 4 pixels trimmed off the edge, and yes, you can play around with that. I'll bring it back to 0 and play around with the other fields. And also, if you don't remember the names of fields exactly, you can tab these. So if I got an R and tab, it can suggest you mean row mask or row mask flag or whatever. But it's a handy way to experiment with scene mode and all the fields. Instead of manually fiddling around with bit fields and pokes, you can do it that way. So that's pretty cool. Oh, if you want to know all the fields, yeah, you can just do a dot and then tab, and you'll get a big long list of fields. Poke can set values as binary, decimal, or to a symbol name. Yeah, okay. We could try that. Alright, I'll just reset T0. Alright, let's get out. Yep. Let's try. So, what was the thing? Poke can set binary. Okay, so they suggested an example. Poke 800, the screen memory, with the value of 0A, a hex value, a decimal value, and then followed by a binary value. So we should get 3 characters, and they are all J. Yeah, okay. You can also poke specific bit fields. So if I was to poke 004D, but only bits 4 to 7, with the bit value of 1111. We get a before and after. Before they were all zeros, and I put 4 to 7 now as 1111. Okay. Yeah, we can preview scene characters. You've seen that. We can print watch variables in any form we like. So I guess I don't know what kind of things we print. byte, or no, let's do print word 16. Like let's say this is usually address 16 is which line number of basic we're currently running. Okay, let's say if I run this program and if I do pw print the word at 16, that's not very helpful. Did I get that wrong? I was pretty sure it was 16. What if maybe I'm mistaken, or maybe because it's in a loop or something. But anyway, whatever. Maybe we want to see that in decimal form. So then if I put /d, we can get that in decimal form instead. Oh, what was it? We can have it in binary form, is it? Oh no, we can't do binary for this. Oh, I thought we could. Oh, maybe it's only for byte, is it? So what if I do PB of 16? FF, can I do it in binary for that? Okay, I haven't done that for words, only for, okay. Calypso compiler debugging support, that's in built now. I think that was needed for which project? The intro disk project. Yeah. Can I exit this one? Okay. Or maybe again I can I run it from here? I forgot how to run the intro disk from the make file. Xmega 65. So which target runs this? Run. Okay, make run. So if I do make run, I should be doing it from from MinGW. Make run. All right, this will go straight to the intro disk, the new one, and then debugging that. I don't have much memory of what I want to debug there. What if I just pause the CPU and disassemble? I cannot recall what I'm doing. Somewhere else. This or symbols. Can I get some symbol names maybe in a range? Any symbols? Oh, maybe I've done it wrong. Maybe from or didn't it load any symbols? No, it didn't load any. Oh, I'm in the wrong directory. I probably have to do like in the build directory or something like, or binary directory. I think, yeah, maybe I should run. No, again, it's not here. Where's the when it builds? Oh gee, I'm in the mess. When it builds, what were the files it makes for list files or something? Yeah, it goes in the executable directory. What's the executable directory? exe. Okay, so maybe m65dbg in here, and we load lots of labels. Okay, so now if I do disassemble, it's not going any symbol. Any symbols around? Lots of symbols. Okay, disassemble one of these symbols. That's not a very interesting looking symbol. Okay, MP loop. Can I do that? MP. Oh, that's not terribly exciting. But at least it's showing. There's some elements of this working. Like you could do print byte of MP loop, and it says it's equal to 1, which, yeah, that makes sense. I wish I could have shown you some source code stepping. Maybe I could if I knew what I was doing. It's been just so long. Maybe if I step around a bit, will it catch something of interest? Maybe not. Yeah, not a good demonstration. I mean, maybe if I get familiar with the source again, I don't know how quickly I can do that. Is there a main or is there a? I guess it's main. Oh, it's also C code as well. Yeah, but the C code got compiled down to the list files assembly as well, I think. So, are there any functions in here of interest? Or this is just one big main program? It's just one big main program. So there were some assembly files with it. I can't remember. I thought so. No, it's in the source folder. Um, RQ main. Yeah, I think, alright, maybe this one's more interesting. Public IRQ main. Okay, weight lower border. Alright, that sounds promising. Okay. Break on weight. Can't find it. No. Oh, I'm in the wrong folder again. XE run up. Yeah. CXE. Okay. Break lower. Oh, weight. Weight lower border. Oh, maybe I should disassemble that. Yeah. Okay, it's disassembling right. Maybe I should make the thing bigger so we can see it a bit better. It's very verbose. Yeah. I don't know if a break will hit, but we can try. Alright, I'll step through. I don't know what kind of weight lower border it is. Yeah, I don't know what I need to do. But at least there's some hints that some aspect of Calypsy debugging is working, but yeah, I haven't demonstrated it terribly well. So it doesn't matter. I'll just exit from here. How do I exit from here again? I can't remember. Oh, I have to go to intro select. No, it's struggling. Okay. All right. Yeah. Hippo services. Yeah, you can call some Hippo services, not all. Let's help Hippo. Yep, so you just have to give a service name. Not all service names have been added yet. It's sort of by a needs basis. I sort of add them one by one because they all seem to take different parameters, which I need to offer as, parameters you can type in. Um, so available services. I think the one I called here was Hippo get proc description, which hopefully doesn't need any get proc description. Okay. All right. So we got some image about which disk is attached to drive 0, which disk is attached to drive 1. Okay, so yeah, and that's via the Hippo call get proc descriptors. I wonder if get mapping will do the same thing. Hippo get mapping. I thought some of these might need. Oh yeah, we've got the map-h, map-l, and also the megabyte selectors as well. Which other ones do we have here? Get version, get error code. Okay, many of these don't need get error code. Did I spell it wrong? There's no underscore. Error code, no error. Okay. Oh, maybe something like set mapping. Yeah, that would need some parameters. If I do it on its own, okay, here we go. Arguments, you need to provide a map-l value, a map-h value, a megabyte low and a megabyte high value. So if we were to want to alter the mapping, let me just do hippo get mapping again so we know what it is currently. It's probably a too crazy thing to do. Hippo set mapping. Let's make it B400 and this is map H first. What was it? Map. Oh, it's map L first. So it's map L first. Okay. E400, then B400, map L, map H, then megabyte low. Let's make it the first megabyte of each. So something like that. It's a pretty silly thing to do, but hopefully it works. Maybe it's not happy with me doing that. Oh, now it's executing code that it shouldn't. Can I pause the CPU? Oh, that was also something. These kind of errors in Zemu, before it only offered these first 4 options. On my branch, I've offered the pause CPU if we want to inspect, what happened. Doesn't work terribly well, but okay. Now what if I get mapping? Did it change it to what I wanted? Yeah, map page is now B400, E400, and we're at the first megabyte of each of these. Yeah, okay. That's probably a silly thing to do, but I'll reset. Okay, capital Z was a hacky UART monitor thing to save a triggered trace to a file. It's hard. I bet I didn't even document that. Yeah. It's a dodgy Zemu hack. I think it's on occasions like I was interested in capturing CIA timer information, and so I used a capital Z in my tweaked like a Zemu code to start triggering the saving of CIA information to a file. Maybe if you're interested in that sort of thing, you can look at the GitHub commit history and track this one down, just in case you want to record some information like IO information that changes over time into a file. It might be an example of doing that. The B list is like the listing of basic programs. So I can list an entire basic program with just typing B list. Okay, that's not a particularly attractive one, but maybe I pick a different one. Um, is there any other programs that are nice on here? Oh yeah, okay, I'll load family. Basic program too, I think. Okay, oop. Why did it exit? Oh, I don't need to run it from here. Okay, debug. B-list now. Okay, that's a short little basic program there. Okay, if we do help B-list, we get a sense of, we can add /d for getting the debug stuff alongside this. Actually, before that, I'll do, if we want to put just a single line, maybe we just want to see what line 10 is, we can do that. If we want to start to finish range, we can do that. If we just want up to an end range, I think I put a hyphen for the start. Yep. And if we want to see debug information alongside a line, let's say to do /d and do line 10. So this is telling me that this line 10, screen blah blah blah, is located at memory location 2054 and consists of these bytes. So if I was to do a memory dump of 2054, yeah, I can see that there's 640, 400 for the screen line. Just in case you want to study the byte specifics of a specific line, it could come in handy. That's it. That's a B list. Oh, and you can also add a search term here. So if you were searching for a particular line, you could do B list and maybe search for the word load. Does it have to be? I didn't think it was case sensitive. Oh, I guess it is case sensitive. Yeah. Um, 11 support added here. Because I tend to program in 11 a lot, I find it handy. It'd be nice if I could refer to, I guess, 11 variable names and 11 label names inside m65dbg, and there's some support for that. But you need the latest version of the 11 to do this sort of stuff. So to demonstrate that, what can I do? What program was I doing in 11 recently? I've completely forgotten. Um, I guess maybe Silent Enigma? Um, yeah, maybe. I think I did a little bit of Silent Enigma recently. That's in intro disk right now. So I exit from there. I'll go into Silent Enigma, make Zemu in here. And I think I remember doing the bass logo stuff in here. Oh, that reminds me, another perk I added into my fork of Zemu was that I now can let the control backtick key jump with the fast clock. So you see at the top here it says 40 megahertz. If I do control backtick, it becomes 200 megahertz. If I do control backtick, it goes back to 40 megahertz. For me, it was just a quick way. Let's say if I load basslogo.l, okay, you can see how slow. Like if I go page up, page down, and if I now do control backtick, page up, page down is a lot faster. It's also a difference when compiling. If I do F5, you can see at 40 megahertz, it's pretty slow. If I do control backtick, it chugs along a lot faster. So yeah, that's that. Maybe I'll let it compile And this was just the BAS logo uh, example on its own, which I sort of recently tweaked. Um, so yeah, maybe if I want to debug that for some reason, what's yeah, I should do it in silent. If I do pbas here, what's that give me? All the variables of the program. That's a new thing as well. I get a list of arrays in the program as well. So if I did want to look at an array, I could do pbas a, and I think it'll tell me what's in A25. A25 consists of these 25 values. So that's handy if you're looking into arrays. And I think it works for multi-dimension arrays as well. But I was more curious about, this is more about pbas and an 11 variable name. Okay, so if I will, how do I compare the source? Okay, maybe if I look at bas logo.l, the 11 source on my side here, and as I'm looking through this source, I might see if logo state is something. So I know there's a variable called logo state. So maybe I want to look for that here. Yeah, good point. Is it? Can I do logo state? Uh, uh, or do I need like a special character? I've forgotten. Should I do symbol to give me a clue? I honestly can't remember. I have a. I probably should have prepared that top right. Oh, maybe actually it's in the list itself. If I do list at the bottom of the list, okay. Oh, maybe it's all capital letters. Logo state. Could it be pbas? Or maybe let me just try. PS logo state. No. All right, let's try logo state. Nope. How about pbas default? Or am I running it from the wrong location? Oh, before I do this, I think I need to do a blist command. That's right. The blist command will scrape for those rem comments and get that information out. And now if I do pbas logo state, there it's found it. Okay. All right, there we go. PBS logo state. Maybe if I want to list from one of the label points, let's say draw Petsky frame, can I do that? Can I do blist draw Petsky frame? No, I can't do that. Oh, maybe it doesn't recognize a symbol name. Symbol draw Petsky frame. No, that's not very helpful. Um, I thought this would have worked, but anyway, it should work one day. Um, okay, I guess draw Pesky lane 969, business 969. Okay. Anyway, you get the gist. If I want to see default red, print bass, default red. There we go. All the default reds in the array. Yeah. So that, yeah, I guess that kind of shows that aspect. There's a bit of 11 support in there already, and yeah, it can improve over time. You've seen how PBAS can print out array contents. Now there were some PRs worth talking about. C TalkBot provided help categories. These days now, if you type help, he's grouped things into categories. If you've missed the old-fashioned way of everything all at once, you can do help all, and there you go. That's everything. But if you wanted a particular help, like the modify group or something like that, I think you type help modify. No, I'm wrong. Maybe you do help at sign modify. Yeah, okay, then it's just a modifier group. Um, so yeah, that's nice. He also added like an environment variable. If you find you get tired of typing m65 debug with the device here, you might have some other device you want to do, like to your JTAG adapter on some USB port or whatever, or a serial COM port for Windows users or something like that. Yeah, I think he just sets, let's say M65 debug dev in some kind of startup file, or some sort of console startup script, and equals, let's say for me, would I just do TCP? I wonder if that works. I haven't tried this yet, so now I have to do m65 debug. Yeah, it connects straight to Zemu this way. All right, yeah. I've gotten so used to typing it manually, so it's not a big thing for me, but yeah. And oh yeah, Jobon provide support for the Kickass assembler, and so that's working as well. And you've seen the basic back traces. So yeah, that's pretty much all I wanted to show. Maybe as a little reward for people that stuck it through, I can give you a little preview of my sister's boxes. So maybe I'll just jump into OBS and which one is it? Is it the video capture? I think it is. All right. Okay. So, yep. Here we go. Um, Hopefully you're seeing it now. Oops. Oh, it's a bit messy here. So she's got some, I don't know, stickers, I think, which I'll take a look at later. But also, there's different prepared boxes. The smaller sized handmade boxes looking like this. Uh, Pretty cute. And they'll open up from here. I should probably, so yeah, we'll place the floppy disks inside and any knickknacks as well and instructions. So they'll be, she's made 10 of those. So just put them aside here and try and take a, okay. Maybe there's some more paperwork stuff here. These were cute. These were her attempt at 3D printed boxes. So you can see she's made these sort of a very sort of floppy-esque casing. There's a little flick, sort of thumb hole there, and I can open that up. And inside it'll house the the floppy disk. We'll put the manual on top. There's no room for knickknacks there, but maybe yeah, we'll have to make do with these little ones. But yeah, that's pretty cute. Oh, actually, there was another thing she did with this, I think. Was this the one that she added the... Oh, no, it isn't. No, that's just one of the... Okay. Okay, so there's 10 of the 3D printed boxes. And there's also one last box right behind all this stuff. Here we go. The big box. She only made one of this because it was quite involved. Bit hard to get it out there. I might have to make some room to help maneuver it out. Here we go. Okay. This one's a bit more fancy. I don't want to spoil the insides for you because whoever's the lucky one that gets this one. I think the plan is to auction this one off. If I'm being honest, my sister said she was happy to do this for free for me. All this kind of work, making all these boxes was a lot of manual tedium for her. She said honestly, if it was a paid customer, she would ask for from 20k to 50k. So I don't think we'll get something like that if we were auction it off, but just be mindful that all of this was a labor of love. And yeah, for those of you that are happy to sort of support my sister, and encourage her with this project, and hopefully if she can make a few good dollars out of it, it can encourage her to join us in for the next project. And yeah, I welcome you to do that. So yeah, look forward to seeing this get into the hands of customers soon. All right, so that's all I've got for you now. All right, catch you later. I'll just stop the recording.